All right. So the flame in a torch used to cut metal is produced by burning acetylene in pure oxygen. Cool. So acetylene, C2H2, right? This is combustion. You guys know how to do combustion reactions. So it's going to make carbon dioxide and water. We don't need the reaction for this problem, but I'm going to write it anyways just to demonstrate that it's something we've already seen. So I need a 2 right there to balance it. And now that gives me, let's see, 2 times 2 is 4, plus 1 is 5. So with the 2 right there, very quick math, I need 5 halves. And now that is all balanced. And I wanted to balance this specifically for 1 mole of acetylene, okay? And I didn't have to do that for the reaction, but I'm balancing it in this way just to demonstrate to you what's going on, okay? And so this reaction, so I'm going to write the delta H of the reaction next to it. So it says releases, so this is key. It releases, so that tells me delta H has to be negative 1251 kilojoules for every 1 mole. So I'm going to say per mole, and I've balanced the reaction for 1 mole. So I'm good to go there, okay? So now it says what mass of acetylene is needed to cut through a piece of steel if the process requires 5.42 times 10 to the 4th kilojoules of energy. Okay, so how are we going to do it? So I am trying to get to this quantity of energy, 5.42 kilojoules. So I'm going to start with that number. Okay, just like on our process of dimensional analysis, start with what you have or what you need in this case. So what I need in this case is 5.42 times 10 to the 4th kilojoules. And notice that's not kilojoules per anything. That's just kilojoules, okay? So how am I going to get to that? Well, look, here is where I can use my number here just like I do in any old dimensional analysis problem, okay? So I'm trying to get to what mass. So what mass means how many grams, for example. And so I want to convert this energy into moles. And I can do that by using this number. And I'm going to try to cancel the kilojoules, right, because I'm using it in my dimensional analysis, 1251 kilojoules. And here's the tricky part of thermo, because we notice that it's a negative sign for the delta H. But in this problem here, I'm just going to use the absolute value of that number because I'm trying to convert this energy into a mass. So I need to convert it into mass. So that means I don't need the negative sign because you can't have negative mass, right? And so the way this works, because it was 1251 kilojoules over 1 mole, I can also say that that's 1 mole over 1251 kilojoules. And now specifically, that's 1 mole of C2H2, of acetylene, right? And if I look this up on my periodic table really quick, 12.01 for carbon, 1.008 for oxygen, I get that that's 26.04 grams of acetylene for every mole. So the mole and the mole cancels, the kilojoule and the kilojoule cancels. And now I can go and do this problem here. Let's see, 5.42 e to the 4th times 26.04 equals, divided by 1251 equals, and with, let's see, 3 significant digits, 1, 2, 3. This one had 1, 2, 3, 4, but I used 3 because that's the least. That's going to be 1.13 times 10 to the 3 grams. 1, 2, 3. Or 1.13 kilograms, okay? Okay, so again, to summarize, we can use these delta H values just like any other quantity we've used in our dimensional analysis, okay? When we have the delta H of a reaction, we recognize that's kilojoules per mole of any one reactant, okay? So in this reaction, if 1 mole of acetylene is consumed, I get 1251 kilojoules, all right? So that's how that works, okay, from the perspective of the acetylene, all right? And so that means since that's my fuel source, then really that's what I need to use. It's not about how much CO2 I make or how much H2O I make, because I'm using this reaction to generate energy. And so the acetylene is my fuel. So that's really like how much I need to consider using for this reactant, okay? So that's why we're asking what mass of acetylene is needed to use, all right? So let's see here. So I think that's actually a pretty good place to cut it off, and we'll get a lot more practice with these types of things in the discussion worksheet, all right? Okay, folks, hasta luego.